Very good morning, all. Today we are going to discuss about a router architecture, what is going on inside the router, how switching will happen, routing will happen inside the router. We are going to see. We will wait for 5 more minutes. Only 14 students have participated, joined in this room. If you have any doubts, yesterday's class, please feel free to chat. You can post your questions in the chat box. Yesterday we have discussed forwarding some of the datagram virtual circuit networks, connection oriented, connection less, TCP, UDP is a datagram protocol. We haven't seen TCP UDP protocols, but we have seen that virtual circuit, how what is the virtual circuit, how this will work in the transmission control protocol, and datagram, how this will work in the user datagram protocol. Am I audible, ma? Please respond in the chat box so that I can confirm with my audio as well, my mic settings also. Please respond in chat box. Most of times we say that forwarding and switching, these both are the equal terms. This terminology, switching and forwarding, these are the equal terminologies. We use switching more than a forwarding term in our computer networks. So whenever I'm saying switching, you have to remember that it is nothing but a forwarding, just moving the datagrams or the packets from inlink to outlink, appropriate outlink. Okay, is it clear? No one is responding in the chat box. Can you hear me? Okay, good. Why day by day attendance is dropping? Only 38 participants are there till the time. If it is the first hour of the day, in that case, less attendance would be there. Why like that? Any reason? You are sitting at home and taking the online classes. This is very easy, Nama. Okay, I'm going to start my sharing. Today we are going to discuss about router architecture. What is happening inside the router, that we are going to see. Most of times you used to see college department and your home also, you will have access point. That is nothing your Wi-Fi access point. We consider it as the router as well as access point. Wi-Fi access points, for the sake of simplicity I am saying that your Wi-Fi access point is considered as a router. Same like that, you will have different types of routers all over the world. That means your computer department and your finishing school, labs, laboratories. In that, there are so many switches and routers would be there. What happens actually? Routing, we are learning in the network layer about routing and switching. Switching is nothing but your forwarding. Okay, so switching and routing concepts in network layer. How, what actually will happen? We are learning routing is nothing but we are going to place the path with the packet. Okay, or the routing table or the forwarding table. In the forwarding table, if you have the particular route or that particular path, we will follow that particular path and we will move the our network will move the packets or datagrams to that particular destination. But what happens whenever I have my end system, I have laptop or computer or desktop or mobile phone? What happens? It will translate the my English language into some bits and zeros and ones, all the things, and it will pack into the segments. After that segments, it is going to move to the diagrams like this. It is going to forward to the next levels, and at the end, from moving from my mobile to that router device. Okay, or my desktop cable, my desktop to cable, RJ for twisted pair cable, or the fiber optic cable to router. What happens inside that particular router, we are going to discuss today. Okay, first of all, I am transferring the data from my end sender to first router. From router, it is going to follow some set of rules to move forward or the switch that particular packets to the next hop or the particular router. Okay, according to your requirement, it is going to forward. If you have any doubts, please feel free to post questions on chat box. I'm activating the chart here also. Wait a while. Yeah. Now, there are two major functions of a router. Okay. First one is running the routing algorithms or protocols. Routing protocols are routing algorithms. Okay. There are three routing protocols are there inside that we are going to discuss about what is that particular routing algorithm, how it is going to work. Okay, we are not going to deep for this particular routing protocols right now. Okay, RIP, OS, PF, and BGP. These three protocols we are going to discuss in the next slide. But the second function of that particular thing is forwarding the datagrams from incoming to output, outgoing links. Okay, first you see the architecture of your router. You will have the architecture with input link, input ports, output ports. Port is nothing but your RJ45 switch would be there na inside your switch, or RJ45 cable clipping. That particular part is nothing but you consider it as the port. Okay, first port is whenever I am keeping that particular cable is considered as input port. Okay, and the output ports the same thing. It is going to use for output. Here we are using input port and output port is the simplest manner. If it is duplex, full duplex manner, in that case, your input ports and output ports will work as the both the directions. Input port will also take the data and receive the data in that direction. You don't worry about that thing. First, you understand what would be there inside the router, particular router, how it will work. Okay, the left hand side you have router input ports. Okay, first input ports. That means whatever the data comes from cables, that will come to your input port. Here there are three options are there. First one is for physical layer, second one for data link layer, third one is going to manipulate some functions that we are going to discuss. Okay, first three things. In the right hand side also, router output port also, there are three things. First one is queuing, second one is data link layer protocol, third one is physical layer. That means here every router, we discussed in the first session of the network layer, that every router has three layers protocols. That means the set of functions of three layers: data link layer, physical layer, and network layer. Every layer has three protocols. That's the reason here we are not going to looking at transport layer, application layer, system layer. We are not going to discuss. We are not having that particular protocols and that functionality inside the router or any other devices rather than your end host. Okay, in your routers we have only three protocols: data link and network, as well as physical layer. Okay, here in the inside the router, input links ports are there, output ports are there. Along with this input ports, output ports, we have switching fabric and routing processor and switching fabric. These are the two extra things. And your switching fabric and routing processor, switching fabric is the main part of that particular thing. It is a work like a network. What happens when you are having more than one cable input ports? Okay, I have left side 10 5 input, you consider it as 5 input cables are there. That is uh, fiber optic cables are there, or ethernet cables are there. 5 ethernet cables are there at the left side input port, and the right side we have 5 or 6 output ports or ethernet ports. Okay, your switching fabric is going to work as a network to whom it has to connect. First port, whenever the data comes from that particular first port, it is going to check the header of that particular datagram, and it is going to forward to, with the help of, here you have the forwarding table copy. In that, in the input processor only you have forwarding table. Your switching fabric is working as a network inside your route. Network inside switching fabric is nothing but network inside your fabric, inside your router. Okay, routing processor, this is nothing but your software part of that particular thing, software part of the particular thing. And the here you see the dot line is there. Under the all the things are the components, are the hardware components forwarding data plane. Okay, all the component input ports, output ports, switching fabrics, these are the all are the hardware components. But in case of routing processor, this is managing control plane. This is the software component. It is the software component. Your router is combination of software and hardware. So switching input ports, output ports, and switching fabric is the hardware components. And the routing processor is responsible for routing algorithm, all the things. That is the software component inside your router. Okay, is it clear, ma? Now we are going to see what are the routing algorithms are there, protocols are there, that we are going to see here. Routing information protocol, RIP, routing information protocol. It is a dynamic routing protocol which uses hop count as the routing metric to find the best path. That means routing algorithm is nothing but I am going from one place to another place. That means system 1 to system 10. Okay, how to move from system 1 to system 10? In the in between there are so many routers, some other different paths, the different hops means if you have system 1 and system 1 2 3 4 5 2 3 4 5 6, like this you will have 8 more systems, as well as you will have routers and switches also there inside that particular network. So whenever I'm forwarding that particular data from system 1 to system 10, it is just checking the how many uh, devices, or you can say consider as hopes. Hope hope is nothing but your devices, either it is the intermediate end device or the network device. Okay, how many hopes are there inside particular thing? If it is going through a one path, in one path it is going to find the three hopes. That means it is the best small if it is finding other path which is having more number of devices. More number of devices mean 5 to 6 devices. In that case, it is going to choose the less number of hope path to transmit the data from sender to receiver. That is nothing but it is going to count the hope count. It is going to count the hopes or the network devices to has a routing matrix. Whenever if it is finding the less number of routers or less number of network devices hopes, in that case it is going to choose that particular thing to transfer the data from source to destination. This is the routing information protocol, RIP. RIP means nothing but it is going to count the number of hoops between the sender and receiver, or that particular path, within that particular path. In which path it has the less number of hoops, it is going to choose that particular path. Okay, that is nothing but RIP. Open shortest path first. Open shortest path is a link state routing protocol. Okay, link state routing protocol means it is going to find that particular link is busy or the thing, and all the state is going to consider, and it is used to find the best path between the source and destination router using its router own shortest path first. Okay, first it is going to choose shortest path first, and it is going to consider that link state also. What is the, is that particular link is busy or free? In that case it is going to choose another paths also. Okay, open shortest path first, this is the link state routing protocol. It is going to use its own shortest path first mechanism in this particular thing. Okay, this is the second protocol, open shortest path first. Our routing information protocol, it is going to count the number of hopes between the sender and which is having less number of hope count, it is going to choose that particular thing. Okay, border gateway protocol, this is the exchange routing information. That means you have different types of autonomous systems. That means KMIT using some protocols, all the things, and it has own LAN. Okay, now I want to connect to NGAT also. Okay, KMIT to NGAT. In that case, the bridge gateway autonomous, this is the different autonomous system. That means we are in KMIT we are using act fiber net. Okay, in NGIT we are using Airtel or some other Hathway or some other ISP. Okay, the two different ISPs we are using here, act fiber band, there Hathway. In this case, where border gateway protocol is used to exchange the routing information for the internet, and it is protocol used between ISPs. Okay, in that case, we are going to use border gateway protocol. Border gateway protocol we are going to use. It is different autonomous systems in different autonomous systems and different ISP, internet service. ISP is nothing but internet service provider. Here we are using ACT, there we are using Hathway. Because of this particular exchanges thing, we are going to have border gateway. Here we are going to use different protocols and all the things, there we are going to use. So at the end it is going to match with the both the things, so transfer the data properly without any translation issues. That's the reason we are going to use this border gateway protocol between two different autonomous systems. Okay, these are the three protocols mostly mainly used in this particular routing processor. Okay, this is the software point of the particular thing. This is the software point of, we are not much we are considering this particular routing protocols. Just we know that we want to know that particular thing, that the reason we are discussing this. Okay, now we are going to see the hardware point here, input switching fabric, output ports, all the things we are going to see. Okay, one after another. First, Input port functions. What will happen when input port functions? What is going to be happen in input port? Okay, first, termination is the first thing. Line termination is nothing but your physical layer responsibility, bit level reception. That means bit level data will comes to your line termination. All bits and bytes will come to your line termination. That is the physical layer thing. Next, data link layer. Next, link layer protocol framing, all the things will be taken care by your link layer protocol receiver. Here you have second step in this particular thing, framing, and all the things will be taken care here. Header information we are going to see in this particular thing. This is the first one is physical layer things. Reception will be bits and bytes. We are going to reception that particular thing. In the second thing, we are going to see the link layer protocol receives that particular thing, Ethernet, all the things we are going to consider, the all the protocols we are going to consider here. Next, third one is going to decentralized switching. Third thing is decentralized switching. Here what happens, first of all, whenever I'm seeing that your routing processor is there, inside that particular routing processor you are going to have the routing tables. Okay, these particular routing tables would be there. According to that routing table, we are going to forward that particular data to the outlink. Okay, with the help of switching fabric. Okay, some of the particular things what will happen, this is the datagram. It is going to find out the it is going to check the, it is going to have the copy of this routing protocol or the routing table or the forwarding switching table, also we can call it as switching table copy would be there. In that, it is going to look up that particular thing and it is going to forward to the switch fabric, and it is going to have the queuing facility inside the particular thing. What is that? The three things we are going to see. First, lookup. First of all, whenever you are going to get the a packet, it is going to find out the to which it output link we have to forward. Okay, that is the first lookup inside your table, forwarding table. Okay, next, forwarding. Whenever you find out this is going to xyz port or this xyz output link, it is going to forward to the next switch fabric. Okay, switch fabric is the another component, hardware component, network component inside that router. Okay, third one. Okay, queuing is nothing but whenever I'm getting the data from source. Okay, my Ethernet or my cable capacity is 10 Mbps. It is forwarding more than that particular 10 Mbps bit rate, not more than 10 MB bit rate. It is sending. In that case, what I will do, first of all, I will get the information. I will keep it in the queue of whenever the switch fabric, the first datagram or that particular moves to the switch fabric to next that particular next output link. There must be some gap between that particular one frame to another frame to translate that particular data in the switch fabric and the output. The timing would be considered and the queuing will be considered by your this part of your input port function. It is going to check if it is more than particular thing, it is going to keep it in that particular queue. Okay, decentralized switching. In this is going to done by input port function. Given datagram, destination lookup output port using forwarding table inside in input port memory. Match plus action. Match plus that, first of all, it is going to match that particular thing, and whenever it finding the match particular thing, it is going to forward. If it is not matching, if it is not finding that thing, it is going to add new thing and it is going to forward. Okay, next, what is the goal of decentralized switching? Complete input port processing at the line speed. That means whatever the line speed is there, and the input port line speed is there, according to that particular thing, it is going to process that particular lookup and forwarding thing. If it is exceeds, in that case, it is going to queue the frames or that particular datagrams. Okay, queuing. If the datagrams arrives faster than the forwarding rate into that switch fabric, it is going to queue that particular thing and it is going to forward one after another one. Okay, first one is this one. Next, switching fabric. What is actually switching fabric? There are three types of switching fabrics are there. First one is memory, bus, cross. Switching fabric is nothing but it is a network behind that particular router. Okay, what it will do simply, whenever transfer the packet from input buffer to appropriate output buffer. Okay, whenever you are going to here I have, here you see I have queue. In this queue I have buffer space also. Without buffer space I am not going to keep my datagrams inside my this particular input port. Okay, input port I am not going to keep the packets or datagrams. Whenever I'm transferring that particular thing at the switching fabric, that it will take that particular packet from that particular input buffer, and it will forward that to appropriate output buffer. Output buffer is nothing but output link. Okay, output link. In between there must be one packet gap must be packet gap time must be there inside particular thing. Okay, there are switching rate, and it is going to consider a switching rate. If the switching rate is more than that particular thing, can be transferred from the inputs to output. The rating is nothing but whenever I'm getting the packets, I will forward that particular, I will process that particular packet and I will forward to the output link. Switching rate is nothing but often measured as multiples of input output line rates. Okay, what is the input line rate and what is the output line rate, that I know. According to that, I will, as a switching fabric is going to forward that particular thing. N input switching rate, n times line rate desirable. Okay, n inputs. If you have switching rate is nothing but you have 10 lines. Okay, 10 cables, input cables are there. Okay, and 10 cables are there. 10 cables with one cable is 10 mbps. Okay, switching rate is nothing but nothing that. Okay, what is there, ma? You have any route 450? Please let me know. 450, do you have any doubt? You raised your hand now. Okay, now switching rate is nothing but if you have 10 cables from input and each cable have 1 mbps, in that case your switching rate is 10 mbps. Okay, n into switching rate of one line rate. Okay, that is 10 mbps for that particular thing. There are three types of switching. How these types of three types, first one is memory switching fabric, bus switching fabric, and crossbar switching fabric, that we are going to discuss in the next slides. How the memory switching would be happen, switching fabric, and bus memory switching fabric, and crossbar switching fabric, one after another we are going to discuss. First, switching via memory. This is the old and traditional computers. In this, what will happen, there is a processor would be there inside particular thing and memory would be there. Just first it will packet copies to the system's memory, and it is going to copy that particular thing, and it is going to copy that particular datagram to that particular memory. Speed limited by the memory bandwidth. Whenever it is first, it will, what it will do, it will take the ethernet packet or the particular datagram from the input port datagram. It will consider datagram or that particular information it is going to consider, and it is going to copy into the memory. And whenever it is finding that particular thing, it is going to appropriate, it is going to forward that to appropriate output link. It is going to forward to the appropriate link or the output links. Here you can see the input links, input ports and output ports. That is the RJ45 devices which we can insert the RJ45 cables inside that particular thing. Okay, RJ45 would be the Ethernet ports. Okay, these are the ports. You can find it here on the left side and right side. Okay, whenever I'm transferring the input port to out, in between there is a memory would be central CPU would be there. That particular processor will take care of copying that particular system's memory and speed limited by memory bandwidth. That means speed limited by the memory of bandwidth, memory bandwidth. Two bus crossings per datagrams. Two bus crossings means whenever the data transmission from here to two buses, that means two uh, crossings, if it is moving from two crossings, this is the one crossing and the second crossing, if it is moving more than it is going towards crossing, after it is reaching the after moving the second crossings, then only the next packet is going to start from the input port. Okay, two bus crossings per datagram. Okay, two bus crossings from per the datagram is the speed limited in memory switching fabric, or switching via memory. Okay, next we are going to see about switching via bus. In this technology, we are going to have a bus between that particular thing. Thus, but bus has the bus capability. That means bus has 32 GB per second. It can capable transferring the data, and each and every data packet. In this case, in first case, we are going to look into the switching memory. In this case, we are going to look into the data from it is going to copy the routing tables at the input port only. Routing tables are the forwarding tables in input port only, where whichever the output link is there, that copy that particular output link port in destination port thing would be link would be information would be copied to the memory, and it is forward to the same to the that particular output ports. Okay, in this case what it will happen, we are going to label some such a information. It is going to, if it is ABC, input ports are ABC and outputs are you can XYZ, I have to forward the data input port A to Y. So every datagram will have having that particular, it is going to look at the routing table and it is going to label some information is nothing but X, it is going to go to Y cable only, Y output label. So I will have a sticker on that particular thing, I will forward to the bus. In bus, the data is transferring that particular bus from here to up to down, and whenever it finds that particular matching information, the cable information output link, in that case it is going to forward the data to the particular out link. Okay, if it is not matching, in that case it is not going to transfer that particular bus data from input port memory to output port memory via a shared bus. Shared bus means nothing but you will have a bus cable connection would be there, switching by that cable would be there, that in that cable we are going to pass that particular. Whenever it finds that particular output outlink address is there, in that case it is going to forward in that particular thing. These both are, first and second are the single datagram. That means we are not going to single processor systems. Okay, at a time it is going to process only one datagram, not more than particular one datagram. Okay, every time it is going to process only one datagram. Okay, the bus capacity is 32 GB per second. So according to sufficient speed for the access and enterprise routers. Okay, enterprise for the medium level, that particular thing, bus type of switching is more enough. We are going to have 32 GB per second bus would be there inside the particular switching fabric. In that we are going to transfer with easily, we can Cisco 5600, that is the type of that particular fabric. Okay, now coming to the crossbar. Give me a minute, ma. Okay, now we are having only single packet to transfer from in the bus switching. Now coming to the, I want to transfer, I want to speed up that particular thing. I have multiple number of cables are there, input ports. So I want to forward, each cable has forwarding some different data to that particular switch or that particular router. In what case, in how it is going to be overcome? That means more number of data will be. In that case, what will happen, if you are using bus, it is going to stop here at the queuing level. One after another we are going to forward that particular thing with that particular. Now in case of, if we are having more data to transfer in the multiprocessor, in crossbar is the multiprocessor system. Here every bar is going to be have the crossbars. It is controlled by this crossbars is controlled by your switching processor is going to be controlled this particular thing. Switching processor is going to control this particular thing. Okay, Bunyan networks, crossbar, other interconnection networks initially developed to connect processors in multiprocessor. Here till now we have seen only one processor is considering that particular thing. Only one processor means we are not going to have single processor thing. The data is transmitting very slow. But here we are going to have multiple datagrams can pass over the crossovers. Here what it will do, it will, whenever it reaches that particular thing, it is going to find out that particular outlink port, and it will open that particular, this cross will be opened by your network processor, routing processor. That processor will open that particular thing. According to that opening that particular thing, it is going to move that particular to your next input output links. Cisco 12,000 switches 60 Gbps through the interconnection networks. Okay, via switching, via interconnection. This is the crossbar or interconnection network. Switching via interconnection, we are going to have 60 GB per second switching capacity in crossbar. We having Cisco 12,000 switches have this particular processor. In this particular, data will be transferred very fast. Now we have seen first one in input ports, inputs input ports. Next, fabrics. Now we are going to see output ports. The same thing in output ports also, we are going to have, first one is datagram buffer will be there. Datagram buffer, this according to the link, there may be a chance of input link is capability is more and output link capability is less. That means input link is 100 mbps and output link is 10 mbps or 2 mbps. In that case, what will happen, your buffer and queuing will considered in that particular thing. If the input link is very less in bandwidth, that means 2 mbps. If the output link ports are the links are the 10 mbps or 100 mbps, in that case it is going to transfer the without any issues. It is going to, we are queuing, we are not going to have the queuing more probably. Why? That are 2 mbps, these are the 10 mbps. So okay, output in this also there are three things. First one is datagram buffer queuing, and second one link layer protocol is going to do in the and output port. Okay, in output port most of times we are going to have link layer protocol and physical layer and data link layer protocols is going to work inside this particular output ports. Okay, buffering when the datagrams arrives from the fabric faster than the transmission rate. That means your outlink is capable of 2 mbps, but the data is transferring from switching fabric to your outlink very fastly than 2 mbps. In that case, you are going to have the buffer space, that is memory, would be there inside that particular thing output where you are going to stay. Okay, scheduling discipline chosen among the queued datagrams for the transmission. Okay, in this particular thing, if you have queuing that particular thing, we are going to schedule one after another. After 2 seconds we are going to transfer that particular frames. Queuing, scheduling discipline, scheduling would be there to transfer the datagram one after another. Otherwise what will happen, everyone will wants to go into that particular teeny link. It will make the traffic burden to your link. Okay, it is not good. That's the reason scheduling discipline is going to use here output link. Okay, output ports. Okay, this all things will happen inside your router. Okay, output queuing and input queuing. Output port queuing, why, how the output port queuing will happen, we are going to see. Buffering when arrival rate via switch exceeds the output line speed. Simple. Queuing, when you are going to have the queuing, either that particular fabric is not going to, it is slower than your input link, or your fabric is faster than your output link rate. That is, link rate is nothing but your bandwidth or the particular thing. If it is the, this link is 2 mbps or k 1 mbps, your fabric is okay, good question. 446. So we already do flow control in the data link layer queuing. Why again buffering queuing here? You haven't listened here. Here output port is there. In this, what we are doing, ma? This datagram we are not we are not switching here. Just your link layer protocols and line termination only. But why here I am checking these particular things? First of all, I will forward that thing, particular flow control and error control, flow control thing is there in your data link layer. Link layer also working on here only. Link layer also here only. And flow control, it is the different from this particular thing. When I have here network thing is going to do. 1 minute, I will tell you. I have a, give me a minute. Okay, I have a switch. Okay, switch or router. Okay, in this I have 3 cables. Okay, output 4 cables or 2 cables. Okay, your data link layer and physical layer, what it will do, one sender is there, but and one receiver is there. Okay, here in data link layer, what it will do, sender and receiver, only one person is there. That whatever the data is transferring, that data will be considered as one and another. Okay, here I have multiple number of input devices. That means this particular first input is this is the sender 1, S1. This is the S2, and this is the S3. 3 different senders. Okay, I have to forward this particular through here. Give me a minute. Here I am going to forward switching fabric. Switching fabric is F. Okay. Okay, these are the different, but your data link layer and physical layer are considering your S1 to S1 only. Okay, S1 input to, this is receiver R1. Okay, this is R2, receiver output link. You can output port. Okay, this is the sender 1, sender 2, sender 3, receiver 1, receiver 2. This cable again, you will have the total LAN. That means this is the switch between the two different LANs. This here you will have different machines. This here you will have different machines. This particular input or output connection connected through internet also. Okay, the router has the combination of input and output. There may be connection have internet, and there may be connection to that particular thing. This is the next hope. It is not a problem if you are connected through this particular thing. If you are connecting through another router, in that case what will happen? Okay, here we have different networks and different machines. Flow control and data link layer control, we are going to consider one sender and one receiver only. Physical layer and data link layer responsibilities are that particular thing. And data link layer, if you are accessing first, one sender is sending some information that is going to access, if it is the link is very busy or not. Multiple access controls and link layer controls, it is going to check bit stuffing, byte stuffing, all the things. It is going to check that particular cable is capable or not. It is going to, we are moving ahead that particular thing. The different particular things, we are having the packet information, data information. According to that packet information, the header, IP address, that particular thing, to whom I have to forward. That's the reason here we are having queuing all the things. Are you clear, ma? Data link layer, only one sender and one receiver would be there. And media access control, if the more the particular thing, more the users are there, more the senders are there, more receivers are there, in that case what will happen? It is going to find the whether that particular cable or that particular link is free or not. But here we are doing behind that particular thing. We are multiple packets are sending. Each packet has its own destination and sender and destination addresses. According to that, we are switching that particular thing inside that particular thing. Whenever I'm switching, I have to forward the S1 data to R1. Okay, I have to forward that particular. Here I have 1 Mbps capability of this here. You are thinking that my data link layer will take place now, sir. But your data link layer, where the data link layer will do at the receiver end particular thing only, or it is going to check. So here we are checking transmission rates between it's two, not two networks, two links behind the your router. We are checking the transmission rates of your two input and output ports, which is coming to the router. Your switch or your access point would be there now in your home. According to that, there will be input link would be there, output link will be there. Okay, output link is nothing but you are connecting to your mobile phone, which is coming. Input link is nothing but your internet to your access point. Okay, whenever you are accessing here in the whatever you are using inside your home, it is full duplex. That means it will work as the input link as well as output link also. At the same time, your device also, it will full duplex. That means it will receive the information and transmit that. But here switching in labs, in your labs, there would be switches would be there. In that particular router would be there. It will take the input and it will forward to the next levels or the net particular thing. That means you are going, whenever you are sending a mail from S1 to some particular device, it is going to find out particular IP addresses of that particular thing, and it is forward to that particular thing. And we are transferring the link transmission particular link capability, and that particular whatever the speed of that particular data is transferring from S1 to R1 is taken care by datagrams, taken care by this switching fabric and this particular input and output ports here. Okay, is it clear, ma? What is the media access control, sir? As it is already in the data link layer, we fixed particular sender and receiver. Why we are taking the multiple receivers? Okay, media access control. In media access control, we are going to have the different we are same media. That means one cable is there, more than one people, more than one person is logging into the particular thing. That means your Wi-Fi device in your home, more than one, your laptop, your father's laptop, mobile phone, or others, brothers, all the things, you are using the same device, same device, your access point you are using. But how it is going to transfer, is that particular busy, or that particular thing is, the cable is busy or not, that with the help of link layer is going to check. And each and if, here one thing, there are two differences in the data link layer. It is going to check that particular cable or that particular link is busy or not. Now whenever you are connecting to through a access point, every device has its own individual IP address. That IP address and that particular thing will be taken care by your network layer. Which packet is sending, who is sending, is taken care by your network layer. But your data link layer, when the data is transferring that particular this particular person to that particular person, it is going to check that particular device is ready to accept or not, where it is going to take it proper way or not. It is going to check in that particular access control, media access control. Any doubt, ma? 540 446. Multiple receivers, okay, that's fine. If you are cleared, we can move to the next part of that particular thing. Switching, how the port queuing will be happen in the particular thing. Here, packet packets more from input to output. Here we have, we are getting the packets from this particular LAN, okay, with this particular cable. If the particular cable, it has more packets, it is going to keep it in the more packets, it is going to keep it in the queue. At the receiver end, if you are here, you can see the particular clear picture here. The receiver processor is your switching fabric is going to process each and every datagram, every packet, and it is going to forward to the next level, that is output links, okay, output ports. If we are getting more packets at the same time, we are going to have the queuing here at the left hand side. Your blue color, green color, and red color packets are there, that we are going to keep it in the, every packet must be processed with the switch fabric. After processing only, we are going to forward to the output link. We are going to check in the, first we are going to check in the routing table and find out the appropriate outlink port. That particular port we are going to forward that particular simply, okay. For these, it will take some time, okay. Meanwhile, if you are getting any extra packets, we are going to keep it in the queue, okay. Receiver end, our switch fabric is very fast, your information is very fast, your processor is very fast, it is going to manage all the things very fastly, and it is processing and it is sending, okay. Whenever I'm sending this particular thing, it is at this one more thing, whenever I'm forwarding that particular processing very fast, but it is going to forward to the next layer, link layer protocols it has to check, and after that physical layer protocol bits, and it has to check. After that, it is going to move forward, okay. In this we are going to have, if it is fast, rather than this particular, my cable or my link transmission rate is very less, in that case it is going to keep it in the queue, and it is going to forward to the next levels with the queuing forward, port queuing in this particular thing, okay. How much buffering would be there? RFC 3443 rule of thumb. Average buffering equal to the typical RTT. Okay, 250 milliseconds, says 250 milliseconds RTT times link capacity of C. Okay, 250 milliseconds times link capacity. Okay, here you see your link capacity is 10 GB per second. Okay, link capacity C equal to 10 GB per, okay, 10 GB per. Link has 2.5 gigabit buffer space would be there. Okay, 2.5 millisecond transferring time would be there. Because of that, 10 GB per second transfer rate is there. If you have 10 GB transfer rate, also you will have the buffer 2.5 GB buffer would be there. Gigabit now, gigabyte, not gigabyte. Gigabit buffer space would be there in your output outlink buffer queuing. Okay, output queuing buffer would be like this 2.5 gigabit. Okay, reset recommendation with the n flows buffering equal to rtt dot c. Rtt is equal to 2.5 milliseconds, 250 milliseconds into 10 GB per underscore by cross root the root of n. Okay, what is n flows? If you have more number of cables, links, n number of cables, in that case you are going to use this particular formula. Okay, if I have only single cable, in that case we are going to use this particular buffer. And recommendations, if you have n number of flows, and that means sequential flows are there, in that case you are rtt into c by root n we are going to consider as the particular thing. Okay, this is the buffering space you need, how in the input and input port and output ports. Input port queuing, here same thing. The fabric slower than the input ports combined, queuing may occur at the input. If the fabric fabric switching fabric is slower than the input ports, then input port will be combined and queuing may be occur at the input queues. Okay, head of the line HOL blocking. Queued datagrams at the front of queue prevents the others in the queue from the moving forward. Okay, what will happen? Head of the line HOL blocking. What it will do, whenever that particular queue, if you are in a queue, they will stop the others to move in that particular thing. Simple thing. Okay, is it clear, ma, about what is going to happen inside your router? First one is input ports. Next, switch fabric is the processor or the network. It is where we are going to transfer the input data to the output, proper output links. Okay, next, output processing. In our input output ports, we are going to have data link protocols and physical protocols. We are not going to have network things in that particular thing. We are not going to have any networking particular thing inside your input port and output. Only data link and physical layer protocols we are going to have. Switching fabric, we are going to networking that particular thing we are going to. And here input port and output port, we are going to check the information of your header, information of your datagram header information. We are going to have that particular thing, and we are going to forward to that particular header. According to header information, we are going to have the outlink port information in the routing table or the forwarding table. According to that particular routing table, forwarding table information, we are going to forward the data to the next level. Simple. Is it clear, ma? Any doubts? This is all about your what is happening inside your router. Okay, I'm going to activate